Hi guys, welcome to my YouTube channel SK. So guys, today we'll discuss about very important topic in big data that is called as a Hive. So Hive guys is very important in big data. Okay. So in earlier video we have already seen the scoop and or some Hadoop basic commands. Okay. So we as per earlier video we can see like for storing the data we are using HDFS and for processing the data we are using Hive concept. So already how to store we already covered. Now we'll see how to processing the data. So the for processing part we need to use the Hive concept. So I have just divided this Hive concept in around 13 points. So we'll discuss all this point one by one. Okay. So let's come to first question. How to load the data at warehouse directory from any file or any table in Hadoop. Okay, so for that, first steps is like create a schema, load data in table, and then copy data from our local environment to HDFS, then HDFS to warehouse. How to do that one? So first actually we need to create the schema in Hive. So how to create a schema like a create table name, then employee ID integer first name. So that we already means in normally in SQL we are creating the table, right? So same things we have to do here. Only difference is the what is the difference here? So here we just need to add some properties here. So for properties like row format delimited, then fields terminated by comma means all the data means all the this particular data it will terminate by the column, and lines they are terminated by the selection. It will goes to the next line, all the data goes to one by one next line. Okay, and data it will separated by the comma, so that you can change as well like other things also, other delimiter you can provide here. So this property only you need to add in Hive. Normally in SQL you are creating this you are writing this query, right? Create table name and all this schema. So in the Hive only you need to add this particular steps here, else it is similar to the SQL. Guys, Hive it is called as HQL, means it's a Hive query language. Normal SQL is structured query language, and Hive it's come as a like a Hive query language. So this is also similar to the SQL, only just we have some additional things that we can do in Hive, and it's processed on Hadoop framework. Okay. Now next step, in let's suppose we don't need the big concept here. So we need to load the data from local data. Load the local data first. Okay. How to load the data? Means we need to data load from that particular file to employee table. For that you need to run this command load data local in path, and here you need to provide this particular path of our CSV file. Means in let's suppose in our local PC at this particular location we have employee file that we have load into the table employee into table and table name. So this particular file data it will load into this particular table, and for that actually first you need to define the schema for this particular table. Means we have already created the schema here. So whatever data we have in employee data CSV file, the data will move into this employee table, and it will separated by the comma. Okay, so you need to run this command load data local in path. Then how to load the data to HDFS? Now we have the data in our particular table. Okay, so for that we have some steps like data will be moved from existing HDFS folder to warehouse directory in HDFS. Now how to copy data copy from employee.csv file to HDFS location? We need to copy the data from one particular location to the HDFS location. So for that we need to use this command like hadoop fs then hyphen copy from local. So and here you need to provide the source and destination path. So it will copy this data from this particular location to the HDFS. So okay, then data first move from local system to HDFS, then HDFS to warehouse directory. And for that, how to do? For that, you need to run the command again like load data in path, and here you need to provide the HDFS path, this path into table name. So only the difference between this command and this command is like Here we are taking the data from in our local system, right? So if we want to store the get the data in employee table from our local file, then you need to use the command load data local and then in path. And for if you want to use the data from HDFS location, then you need to run the command like load data in path, and this the other things are same. So these are the two, means we can load the data in particular table by using our local system as well and from HDFS also. So if let's suppose if we already have some any input file at HDFS and we have to load the data in table, then we can use this command. If we have the input file at our local system, then we need to use this command. So by using this command, we can load the data from at where question is like how to skip header. Means we can skip our header line first that ID name we are providing some header information, right? So that we can skip. So for that how we can do while creating the schema. Let's suppose here we are creating one table here, like, and then the same things again we need to write like row format delimited, field terminated by and line terminated by. Okay. So after that you just need to use one property called as table properties here. So a table properties you need to define here, and inside you just need to write this command like skip header dot line dot command count equal to 1. So after adding this table properties, you can skip the header. Then how to run the queries? Let's suppose similar to SQL, I need to run the query here. So how we can run the query here? So let's suppose how we can do that one. Let's suppose I need to find the department wise average salary. So how we'll run like select department ID comma average salary from that employee table and group by department ID. So this query performance it will be same to the SQL. So current let's suppose in SQL also we are running the query in this way, and similar way we can run the query into Hive as well. So both are the query language. So select query we can use with same manner. Okay. So that thing we can use here. Then next question is our what is location clause. So location clause means what? Actually, let's suppose we don't want our data on warehouse directory. Means we want to store this data at some of the particular location. So let's suppose if we have multiple files on same location, then schema of all tables should be same. Then we get all file records. So now let's suppose doesn't specify any file, so it will take the directory direct. So let's suppose the local file system to HDFS file load means means whatever data will have in this particular data tree, it will load the data. Means the schema here we are creating a schema, right? So let like create table name, all this we are providing the schema here, right? Up to fields limited by lines limited by. So after that you just need to provide the location. So it will get the data direct from this particular location only. So we can define the location clause. Then next we have how to use join query. Okay, similar to SQL, how we can use here join query. Let's suppose here also we have inner join, outer join, and some other additional joins also we have in Hive. So first, what is left semi join? So this is the one new join present in Hive. It is used for lookup operation. Means same as exist join. Means actually it will give the result same as exist join. And left after join means right table must have schema, and for right side join left must have. So it's opposite. Means let's suppose if you are using right side table means a left join, then right table should have schema. And if you are using right join, then left table should have schema. And we can use merge join as well, means both tables should be for the merge join we have some condition like both table should be in sorted manner. So we can perform the join query here. So we have some basic operations here. Let's suppose for that we are creating schema for one of the table, then we are loading the data from this employee.csv table into this particular table. So and then we are creating one new table and we are loading the data in one second table. So now we have two table EMP, one is EMP and second is ORD order, and we have data from our local file system to this particular table. So now we need to perform the join operation. So how we'll do, select star from this employee table, it will join to department on the condition. That similar operation that we are currently are doing in SQL, right? So in same manner we can use the select query, join query. For left join, you need to write the left outer join. For full join, you need to write the full outer join. And for left semi join, you need to write the left semi join. Uh, so for left semi join, let's suppose we have example like order and customer table, okay, and we need to fetch the data for customer who have ordered something. So it will check matching record from both the table, but in output it will provide record only from the left hand side table. So only match record from right, but result only from left. Means it's similar to the exist join. Means if the same record will present in next table, then it will give the record. So it's a work as this left semi join. It works as an exist join. Then one more join we have in Hive. It's called as a map join. Okay. So what is a map join? I will tell you guys first. So the use of map join. Let's suppose in normal scenario, let's suppose we are performing join operation on two blocks. So employee file, let's suppose it contain 20 MB size data, and department file it contain 200 MB data. Means one file is 20 MB and second file is 200 MB. So for department ID we need four blocks. We already seen ki means the by default block size is 64 MB, right? So for 200 MB data it needs total four blocks. And for 20 MB data it just need only one block, right? So for my first file we have one block only, and for my the second input file I have total four blocks because the data size is the large here, right? So now let's consider means this employee file it will store on only one block one, okay, and department file it is stored on four blocks. Let's suppose block 2 3 4 5. Now, let's suppose if we use map join, what is the advantage of map join then? If we use map join, then block 1 means that employee means this contain only 20 MB, right? So it will this file it put in all other blocks like in 2, 3 and 4, 5. So join is performing with 4 blocks in its own block. Then we don't need to join with other block. So only advantage for this join is only when if we have one small file and other is large file, then only we can go for map join. I will tell with example. I will explain with one of the example because it's very important concept. So let's consider this is the my 200 MB data. Okay, so first means at 64 MB it will convert into one block, then next 64 will come into second block. So for 200 it how much it blocks it will cover, it will convert the data into the four blocks, right? So for my one of the table I have total four blocks, and this second table I have only 20 MB of data, so it will just consist only one block. So let's suppose this is my second table, this is my first table. So my first table data is in four blocks and second table data is only in one block. So normally what it will do, normally how the join operation it perform. Let's suppose first means the data from this particular block. Let's suppose this is my one. Let's consider this is second block, third block and fourth block. So first it will match with this particular block, then this block will match with this block, then again this block will match with this one, and then again this last block also will join with this particular block. So join operation will perform one by one to each block. Means this table will join with first block, then second block, then third block, then fourth block. So it will take some more time. So what map join do, uh, instead of joining to each other to all other blocks, what it will do, this particular blocks, so this block it will move in this particular block only. Means this data now will come, this will data will comes in this particular blocks only, and after that the data it will join itself only. Means now here we have this department data, and in the outside we have employee data. So in this block we have department and employee. So instead of joining to each block, it will join itself. So the time consume it's means we can say it is very time consuming. So that is the advantage we have in map join. So that's why we are going for map join. So you can understand from this logic, means if let's suppose we have one small file and other is large file, then we can use this map join. Okay, so join is performing with four blocks in its own block. No need to join with other block. That is the advantage. Okay, so now next concept is partitioning. So partitioning actually it's used for performance tuning. So this is very important concept in Hive. Okay, so what is partitioning and how we can use partitioning? I will tell you. I will tell one example, guys, so it will be more easy to you. Okay, let's consider you have one table and you have ID, name, and city column. Okay, you have some ID 1, 2, 3, and you have city. Let's suppose you have 10 column and 10 column cities like let's suppose consider Pune. My next is Mumbai. Next is Nagpur. Let's consider Kolhapur. Okay, so you have total 10 number of cities are there. Okay, up to 10 you have total 10 number of cities. Now normal, let's suppose I need to fetch the data from Nagpur location. So normally how you will write the query? It's like you will run like select star from this table name where okay, where let's suppose city equal to Nagpur. Okay, so it will give the results of the city which has the Nagpur data, right? But let's consider this query. It's giving me after executing, it take around let's consider 1 minute. Okay, in normal SQL, if you run this query, so it will give me the output in within 1 minute. Okay, or let's consider within 1 minute, I will get this result. But now let's consider means let's suppose we have only 10 cities, but let's consider if we have around 1 million 2 million records are there. So in that if we have large amount of data, then it will give means this query will run and it will takes around, I can say, within around, it will take around 10 minutes to run this query. Now what we what how to avoid this time space, means I don't need to run this query up to 10 minutes. So for that, in Hive we have one concept called as partitioning. How it works? Let's suppose we have city column and we have total 10 cities. So I will create one partition on city column. I can use partition by, and on city column I use the partition for. So what it will do, guys, this city column means let's suppose we have 10 city. So 10 city, it will create 10 part file for this city column. Means what means let's suppose we have 10, then it will create 10 part file. If we have 100 cities, different cities, then it will create 100 part file. So for each city it will create one part file. Now we have total, if we have 10 cities, then we have total 10 part file, like part 0, then part 1, part 2, and so on up to part 10. Okay, so in my part 0, first part, I have the data for Pune city. In next one I have data for Mumbai city. In next one I have data for Nagpur city. Okay, so each city data, it will divide it into the one particular part file. And when let's suppose we need to fetch the data for particular city, city Nagpur, then let's suppose Nagpur data is present in this part 2 file. So when we run this query, so it will just execute only this part 2 file, not all these files. So it will just take the data from this particular part 2 file. So after that it will give me just that same result within 1 minute only. Okay, so instead of 10 minutes we get the data within 1 minute only, because in normal select query it will first it will go by one, right? Means first it will check what this kind of Pune city, then Mumbai, then it found Nagpur, then it will give the results. but in this condition it don't means go previous cities like Pune and Mumbai. It will directly compare the data from this particular cities and particular part file and will give us the results. So that is the advantage in the partition. Okay, and after that guys, we have one more concept called as a bucketing. That also I will explain here. So what is bucketing here? Let's suppose here we are creating the part file, right? So for 10 cities we have 10 part file, but let's suppose for Pune city we have around 1000 records. Okay, for Mumbai we have, let's suppose, 10,000, and for Nagpur let's suppose we have 100 records only. Okay, so for 1000 records also it will create part file. For this one, for this cities also it will create part file, and for this one it also create a part file. So what is the issue guys here? In partitioning, it will create a small part file for each city. Let's suppose for this one, if we have only 5 records, then also it will create one part file. Let's consider here we have total 1000 number of cities. So for 1000 number of cities, it will create 1000 part files. So for avoiding this small part file, we have one concept called as a bucket. So by using bucketing, we can avoid this small part file. Okay, how we can do? So for that actually we need to use concept like a bucket by. So we need to divide the data in particular bucket number of buckets. So in bucket by you need to first provide the ID, means on which column you need to create the bucket. Let's suppose city column, and how many buckets. Let's suppose I am considering 4 buckets. So now let's suppose if we have 10 cities, okay, and we are using the bucket is 4. So how it will do? Let's suppose we have 10 cities like 4, 5, 6, 7, 8, 9, and 10, and we are using the 4 bucket. So it is using actually mode concept. Okay, so it will divide like 1 divided by 4, 2 divided by 4, then again 3 divided by 4, 4 divided by 4, and so on. So after this we'll get the like 1, then 2, the result is 2 here, we'll get 3 result here, and after 4 by 4 we'll get the mode 0, right? So this 4 number cities data, it will comes in bucket 0, this data will come in bucket 3, and this data will come in bucket 2, and for first one the data will come into the first bucket. Okay, then next like 5 divided by 4, again we'll get 1 mode, then 6 divided by 4, again we'll get 2 mode. So this fifth one data, it will again comes in first bucket, and this data will come in second bucket. So now we have total only 4, we will get only 4 files in output, and for in all these 4 files the data will this all these 10 cities will divide it into these 4 files only. So here we can avoid the small part. Okay, so based on condition actually means based on our input data and condition, we need to select, means whether we can go for partitioning or we can go for bucketing. Both have its own advantages and disadvantages. Okay, so this is the concept partitioning and bucketing. And how we can use that, we can see here, like for use partitioning, we need to set one property in Hive like execute dot dynamic dot partitioning dot mode equal to non-static. So this is actually one of the property that we need to use in that we can use for while using this partitioning concept. We need to define this one. Then what steps, how we can create partitioning here. Create one table, employee table, let's suppose, then load the data from CSV file that we already see how to load, then create another table, let's create one more table and load the data in AMP part 2. Now we have two tables here, right? And then fire the query on both table and check the time difference. Let's suppose first I have created this employee table and load the data from particular this AMP CSV file. Then again I have created, now I have created one more table called as employee part 2. Here similar schema I have defined here. Only difference is like I just add one concept here, partition by, and here I just provide the partition column name, means on which, based on which column I need to do partition. So partition by and that particular column name and data type. Okay, so in this query I just added this partitioning. Now let's see the time difference. Okay, let's suppose I am running this command select star from employee table where my department ID equal to 70. So it will take the run time like 5 seconds. Okay, now let's run the query from second table. Select star from employee part table where department ID equal to 70. Means I am fetching the same records, but I am in my second part table I am just using the partitioning here. So after using partitioning, it will take time only 0.2 seconds. So you can see the difference. This query giving me the result in 5 seconds and this query giving me the result in only 0.2 seconds because of the partitioning. That we already I told in that city example, right? Similarly, we can do here. So that is the difference between partitioning. Okay. Then next, these are the some scenarios we have. So actually we have two types of partitioning like static and dynamic partitioning. So static and partitioning we need to directly load the data from file and then we can use. And normally we are, everywhere we are using this dynamic partitioning here. And for dynamic partition, just uh, make sure कि we should set this Hive property before using this dynamic partition. So all these are about partitioning. Before file format, I just covered this concept bucketing first. We already seen how bucketing is working. So for bucketing also we need to set this one particular property. For partitioning we need to use this property, and for bucketing we need to set this property, and then we can use bucketing concept. And how to do bucketing? So for partitioning we are using partition by, and for bucketing we need to use clustered by. So by using this clustered by command, we can use the bucketing concept. Clustered by, on which column we need to do bucket department ID into how many buckets? 4 buckets. So it will create total 4 buckets based on this department ID column. And other things are same. So this is the concept about bucketing. Now let's come to previous one again. File format. So in Hive actually we have different types of file format. Let's suppose we have like employee.csv. So CSV file format we have. Then Parquet file format we have. So for sequence file format we have. So that we'll see, yeah, one by one. So how to use that one, that also we'll see. So first see how to use the sequence file. Normal CSV file we know, like we are employee.csv file. That file we already know, right? So how sequence? What is the sequence file? So sequence file how we can use, like means after creating this schema, you need to use here like stored as sequence file. So here you just need to add this command like stored as in which format? Sequence file format. So we can change the file format here. Stored as sequence file format. And next one we have RC file. So RC is nothing but row columnar file. So for that also we can use like stored as RC file. So here we can change the file format also. Means we can create we can define this schema and we just need to change the date format here. And then we have Avro file. So Avro file also we have here. And next also we have Parquet file format. So these are the 4 to 5 file format we have in Hive. So we just need to change the date file format here while reading the schema. The next is like what is internal and external table. So difference between what is internal and external means, let's suppose we are creating one table, create table name. Okay, so this is my, by default this is my internal table. Okay, so this table it is created via internally, it will create internally. But let's suppose I then how to create the externally? For that I just need to put the command here like create external. Before table just use the keyword external. Create external table and table name. So it will create the external table. Now what is the use and what is the difference between both? So let's suppose we are deleting the data, means I have one internal table and I have one external table. Okay, and I am deleting the data. Okay, so in internal table what happen? The data and metadata both will be deleted. Okay, because we are using internal. But let's suppose if our table is in external mode. Okay, So in that condition, only metadata will be deleted, but actual data it will be preserved. Okay. So in external table, the actual data will be preserved. It won't be deleted. So that is the major difference between internal and external. So let's suppose if we want to use that particular table in some other application, then we can go with external. Else we can use internal. Okay, so that is main advantages we have with the external table. Bucketing we already covered. Now UDF is nothing but user defined function. Means let's suppose we have some inbuilt, already there are some inbuilt function, but apart from that also we need to use some other function. So for that we can use UDF, means we can create user defined function. So for that you just need to import some libraries, and then you can create one class. Let's suppose two upper class, means let's consider this upper code conversion class is not present in Hive, so you can create a function. So let's suppose I have created one function here, and if the condition and based on this particular condition I will create convert all this data into the uppercase. So I can create UDF as well. And now next is the Saturday property for unstructured data. So structured data we already know how to work. Now let's suppose we have unstructured data, then how we can work, how it works. Actually for that we need to use the Saturday property. So we have one regex Saturday property for unstructured data. So let's suppose if we have recording file in below format, then how to return data. Let's suppose this is the my one of the file I have. Some name are there, comma, then some city and some salary we have. So this is the my unstructured data. It's not present in any table, right? So I need to store this data. So for that, how I can create? First, I need to create one table to upon that particular data. How to create? Like create table name. Here I know ki we have three columns like first name, then last name, then salary and Jaipur. So I will create like first name, last name, city and salary. So I will define total four columns here and create one this table. And while using Saturday property, means already we are using this delimited by separated by, all these things we are using, right? So similarly you need to use like row format Saturday. Here you need to use this Saturday property path, regex Saturday property. So you need to use this command with Saturday properties. Here you need to provide the input dot regex, and how it will see, means how, means here we define this type of data, right? So how we actually so we need to see the input data first, means we have some data here, then space, we have some data, then comma, means dot star, it will indicate the first name, then we have some space, then again we have some name, so again dot star, then we have comma, here we have comma, so it come comma, then again we have some name, so we can define like dot star, after that we have colon, so here we are using colon, then again we have some data, so we can define by dot star and then double quotes. So by using dot star we can define the types, their data, how many data we have in the input file, that we can define here. Okay, and after that it's like hive Saturday property, this is one of the property that class we need to use here. And then we need to load the data, so load data local in path from this particular location into this table name. So in particular table we can load the data. So while creating, actually means while creating the while defining the input schema, we need to use this regex property here. So by using this one we can handle the unstructured data. Now next is scoop to hive or hive to scoop. How we can use scoop to hive? Okay. So let's suppose we are load data to a new hive table. So first exist hive table, then run the new hive after scoop, right? So hive, and first we can check JPS and we can run the jar command, okay? And we need, then actually how we will use. So for that we need to use this command scoop import. This is the my connection detail, again table name, username and password. Up to this already we already seen in scoop ki how we can use this command. So after that actually you just need to add this command here, hyphen hyphen create hyphen hive hyphen table, then hyphen hyphen hive hyphen import. So here means after executing this command it will create one hive table. and we can use Hive import. So we can import the data from Hive to Scoop. But let's suppose if we have existing Hive table, this is the for new Hive table. But let's suppose already we have some existing Hive table and we want to work on top of that table only. So for that you can use like a hyphen Hive table and you can provide the table name and again Hive import. So if you are using new table, then just create Hive table, and if you are using existing one, then just use Hive table and table name. So by using this particular command, you can interact with scoop with Hive. Okay, that is we can use with Hive and scoop. And now let's suppose scoop to Hive. If table is already on partitioning, then it can be used only on static type. Then we need to provide the key value, so it will give you some results. So that is for scoop to Hive. Now let's come to again one of the important question, that is Hive flow. Means actually how the Hive is working in backend. So that I can told that we can discuss now. So this is the Hive flow. It's divided in some certain parts. Like first, let's suppose we have any. Let's consider any input file. Okay. Let's suppose demand has multiple stores. So data in CSV file format, XML, JSON, etc. Any file format. Let's suppose first in starting we have data in CSV file. So first we'll load the data to HDFS. Okay. So HDFS, this is staging area where actually we are storing the data. So now let's suppose we have data on HDFS. Okay. So how it will from, let's suppose here starting the file size is 100 MB. Okay. So then first actually we have next block, pre-processing of data. So pre-processing, what is pre-processing of data? So here actually we can do this slice and dice operation, means like filtering unwanted data, and we can remove unwanted rows and column. Then we can dealing with data type, regular expression, and right shifts in data. So at but this steps first we can avoid the unwanted data, and after that we have one next block is file format. So what is use of file format again? File format is used for storage and performance efficient. Means let's suppose we have 100 MB file here, and this is file in CSV format. But let's suppose if we use the same file in Parquet format and ORC, RC, any other format, so then this file size it will reduce up to around 50 MB and 60 MB something. So for storage and performance, we are using the file format here. And after that, we have processing engine. So here actually, Hive is processing the data in this particular step. Means like data again select query and some grouping, and again all this concept we can use here. And once it will process the data like filter, means all like data join operation, any other query operation. After performing this one, it will give the results to the HDFS. Or here also we can use NoSQL and any other output format we can use here. And then we have one Tableau. So that is actually for automation concept we are using Tableau format. So this is the actually basic structure of Hive. So it always pre-processing the data, then convert into specific file format, then it will process the data, and finally it will again load the data to HDFS or any other location. So in this way the Hive is working. Okay, then for pre-processing, processing like data group by operation, order by, aggregate, all these operation we can use, and we can report to, we can load the data at a particular location. So this is the Hive. Okay guys, thanks for watching my video. If you have any doubts, then you can ask me in comments.